Okay, so far so good. Let's talk about the how part. We talked about the what or definitions. We talked about the rationale, the why, the motivation, and now it's time to talk about the how. So the methods learn through optimizing their parameters. If you recall, every method has some parameters, and the parameters are the ones that actually associate the predictors to the target. For instance, it was the example that income might be modeled as a constant plus a minimum income plus parameter 1 multiplied to the variable or the predictor that is years of education plus parameter 2 multiplied to years of experience. Okay, and this constant, indeed, it is a parameter itself, so it's better to write it as P0. So we have P0 as a parameter, P1 as a parameter, and P2 as a parameter. And these parameters are associating our predictors. This is a predictor, predictor 1, and this is a predictor, predictor 2, to our target. This is our target. Okay? So the model has to optimize these parameters in order to be very good to an acceptable level of quality in prediction. So the methods optimize their parameters in a way that the quality of fit is maximized. We want to have the highest quality of fit. And quality of fit is an equivalent term to quality of learning. Okay, so the model learns through these parameters. How do the methods do so? This is not the topic of in the scope of our module. Okay, how these parameters get optimized. It's important just to know that they are optimized in a way that the quality of fit or quality of learning is maximized. So we eventually measure the quality of learning by a proxy, quality of prediction, and quality of prediction on the testing set. So when our model is very good at prediction on the testing set, we assume that our model has learned from the training set and has optimized properly its parameters. We use quality of prediction we measure quality of prediction through performance metrics. Okay? So we need to somehow measure this quality. And we measure this quality, we quantify it using performance metrics. So performance metrics are basically the metrics that they measure the prediction performance of our model. And if you recall, the performance metric of classification problems was accuracy. So I pointed to that for regression problems. Everything structurally is exactly the same as a classification problem except for the performance metrics. So we don't have accuracy in the previous definition anymore. We have to define new metrics. And accuracy in the previous definition was the number of correct answers to the number of all predictions, the number of correct predictions to the number of all predictions. So we need to define the performance metrics for regression problems. There are many different performance metrics for regression problems, as there are many metrics for classification problems as well. We learned one of those many metrics for classification problem. We would learn two metrics for regression problems this week. So as I explained, one performance metrics for metric for classification problem is accuracy, and accuracy is defined as the total number of correct guesses on the testing data set over the total number of predictions. So if our model has a data set of 100 cases, definitely our model is predicting 100 different values corresponding to 100 cases. And if 80 of them are correct, then our model's accuracy is 80%. Now let's see that how we can define some performance metrics for regression problems through an example.